Section 1.7, rational exponents and radicals. So this section is closely related to Section 5 that we have already discussed, dealing with the properties of exponents. So you still have to understand and be able to work with the properties of exponents in order to be successful with this section. I will say that this section is probably more challenging because of this, because of the fact that you're going to be dealing with fractional exponents. That's what this really means. Fractional exponents as compared to just integral or integer exponents. Okay, so the first thing is nth roots of real numbers. This part at least is pretty basic, I hope. As long as n is even, or if n is even, we must have the value under the radical be positive or equal to 0, and the result then therefore will be greater than or equal to 0 as well. So a couple quick examples here of this. If you have the square root of 16, you get what? Square root of 16 is 4. Why is that? Because 4 squared gives you 16. So this really means if there's nothing here, it's understood to be a 2. All right? If there's nothing there on the radical, the index is understood to be a 2. This is called the index. All right? Again, this is because what? 4 squared equals 16. Another quick example would be like the cube root of, let's make it -8. If we make it -8, you're allowed to have a negative under the radical if it's odd index. Okay, if it is of odd index, like 3, 5, 7, whatever, this can be positive or negative, the value under the radical. So in this case, the answer is -2, and that makes sense because -2 quantity cubed is equal to -8. All right? So the only thing you can't do is something like this. Let's say you have the square root of -4. Well, what's this mean again? It means it's a 2. You can't take the square root of -4 and get a real answer. All right? The answer here would actually be involving the imaginary unit I, which we're not even going to worry about. So this is not going to work in our class. All right? Bottom line, again, to review the index, this little number here sitting on the radical has to be, or if it is even, if this is even, then this must be positive in order for this to work. Okay? If it's odd, it can be positive or negative. If it's negative, you're going to get a negative. If it's positive, you're going to get a positive. All right. So we should be able to go back and forth between an expression in what's called exponential form versus radical form. So if you have any base to the 1 over n, then that's the same as the nth root of the same base b. All right? So here's some examples on the right side. You can see that. 9 to the 1/2, same as the square root of 9. Why? Because remember, this value is really understood to be a 2 if there's nothing there. So this 2 is really sitting right there. All right? Another example, we just looked at this one. Quantity of -8 to the 1/3 really means the what? The cube root of -8, which is -2. All right, the next thing is if you have b to m over n, that's the same as what? That's the same as this, which is the same as what? Well, actually, it's below there. So never mind. So this is the same as b to the 1 over n to the mth, or equivalently, excuse me, I can't talk right now. B to the m over n is exactly the same as the nth root of b to the m. So whatever value is in the denominator of this fractional exponent, that's the value that goes right here on this little ledge on your radical. Okay, that's the index value. All right. So let us now turn to one more thing, negative exponents. Guys, we already talked about this. If you have any base to a negative exponent, it's exactly the same as 1 over that same base to the positive exponent. All right, so keep in mind, let's say you had this. Let's say you had 1 over a to the negative m over n. Well, what would that be equal to then? That's the same as what? That's the same as in the numerator position now, moving from denominator to numerator, it's the same as a to the positive m over n. So it works both ways. It just inverts the base. All right, let's look at these numerical examples. Of course, with any numerical examples, you can use your calculator. That's fine. All right, so the cubed root of negative 27. You could leave it just like this if you like, or, well, actually, boy, I'm not awake right now. I should be doing this later in the day. Anywho, rewrite. Let's read the directions, folks. That's always important to read the directions before you do anything. Okay, I'm awake. Rewrite the number without radicals or exponents. So we are going to base these three examples off what we just discussed with the definitions of rational exponents and radicals. So this one would be rewritten as what? Whatever's under the radical would be negative 27, okay. Raised to the what? If it's the third root, that means the index is 3. That means it's what? To the 1/3 power. Now, obviously, if you wanted to simplify this, you could. And let's go ahead and do that. So after we've rewritten it in this form, if you wanted to do that, you could do what? Negative 3 cubed to the 1/3. All right. So at this point, what would you get? Power of a power, you multiply. So these cancel, right? And you're left with negative 3. So I apologize. I need to have another cup of coffee, I think, to get this thing going. So what we're going to do is we're going to rewrite this without radicals, and we're also going to rewrite this without exponents. So in other words, just simplify these things. Okay, guys? Sorry for the confusion. Just simplify these expressions. And really, you can just use your calculator. But let's go ahead and keep moving forward. All right, so this one really means what? It really means, well, the opposite of 32. So 32 can be rewritten if you really wanted to as 2 to the 5th to the 2/5. That's what this really means. And in exponents, guys, this is in the exponent position. At least it should look like it is. If it doesn't, I'm sorry. Exponents go before multiplication. This really means negative 1 times 2 to the 5th to the 2/5. So this can cancel because a power of a power, you multiply. And the negative stays in front. You get negative 2 squared, which is the same as negative 4. Finished with that one. All right, number 3. Let's look at this negative exponent. So the first thing we can do is rewrite it as 25/9. And now it's raised to the positive 3/2. Okay? And if you really wanted to, again, if your calculator breaks or some weird thing happens, you can change this 25 to a 5 squared. And you can also change the 9 to a 3 squared. And, well, you have a quotient, 25/9 quotient, to an exponent, which means that exponent really is getting placed on every single part of that quotient. So it looks like that. Now, what do we do? Power of a power, multiply exponents. So you get 5 cubed all over what? 3 cubed, which is the same as what? 5 cubed, 125, all over 3 cubed, which is 27. So look, the process is the most important thing here in dealing with these types of problems, because you're going to have to work with variables here real quick. All right. Of course, one more time, if they are all numerical, you can just put them in your calculator. But you should know the process because there's going to be variables happening in just a moment.